Hello, and welcome to the Hella Academy. In this video, we would like to talk to you about a diesel particulate filter's design, function, and testing. Particulate filters are used in the exhaust system to reduce soot emissions. A diesel particulate filter stores the solid particles that cannot be completely burnt in the engine. These nanoparticles are very harmful to humans and the environment, and we will take a look at what this type of filter looks like in a moment. And here we have our diesel particulate filter, our classic stainless steel housing. Further on, we have our connection pipe for the exhaust gas temperature sensor. And this is also where there are two riser tubes leading to the differential pressure sensor. But what does a filter like this actually look like from the inside? To illustrate it better, we have to cut open a diesel particulate filter, and, as we can see clearly here, the following components are installed in a housing: our oxidation catalytic converter. On the other side, we have our diesel particulate filter, a ceramic filter. And this is where the insulation mat is located. This serves to fix the ceramic bodies, also compensating for thermal expansion. Between the two ceramic bodies, there is also a thread insert, and this is where the exhaust gas temperature sensor is installed. Here, we are looking at a single ceramic support with a honeycomb structure. The many small channels with porous walls are alternately closed and divided into inlet and outlet channels. The exhaust gases flow through the filter walls from the inlet towards the outlet, whereby the soot particles are deposited on the filter walls. The increasing number of accumulated soot particles increases the back pressure in the particle filter. The degree of loading or flow resistance increases. A differential pressure sensor, for example this one, is connected to the diesel particulate filter via hose lines and records the exhaust gas pressure upstream and downstream of the diesel particulate filter and passes this information on to the engine control unit. Let's use a vehicle as an example. On this vehicle, the diesel particulate filter is installed behind the engine. This system is equipped with two differential pressure sensors. One sensor measures the pressure upstream of the soot particle filter against the atmospheric pressure. The other sensor measures the pressure downstream of the soot particle filter. The engine control unit compares the data from the differential pressure sensors. In this way, the soot particulate filter's loading condition and ash mass are calculated. We'll take a look at it on a diagnostic device. On a diagnostic device, we selected the corresponding parameters to display the values that the control unit is currently evaluating. To check the dynamic pressure, we now carry out a measurement with the vehicle stationary. To do this, we need to increase the engine speed briefly using several bursts of the accelerator while observing the differential pressure. The differential pressure should not exceed 50 millibars. The result shows a value of about 40 to 41 millibars. This means that the value is within the tolerance and is therefore okay. Alternatively, a test can also be carried out with the vehicle driving. Here, the value should not exceed 300 millibar. If the load limit has exceeded a certain value, the control unit initiates active regeneration. During regeneration, the soot particles burn, but not all particles can be burnt and are deposited as ash. If the maximum ash mass is reached, the filter must be replaced. I hope you enjoyed this post. Thank you for listening, and see you next time at the Hella Academy.